Alright, in today's video we are going to look at notating what we call set notation, interval notation, and writing notation of an inequality. And we're going to write it as an inequality. So let's take a look real quick at this particular topic, and let's go ahead and start showing you the different ways that you can notate these inequalities. So first of all, if you look at this number line that I drew right here, notice that I have a red dot, and notice it's filled in. And then you kind of see a squiggly line. That just represents that I'm drawing a line that goes across this number line to the right infinitely, right? The arrow on the end means that it goes on forever to the right side. Now, there's a couple symbols that I want you to be familiar with, so I'm going to go ahead and write them down. It helps you. You can write them down in your notes as well. So one symbol that I want you to think about is when we have the less than or greater than symbols. So when we have less than or greater than, I want you to keep in mind that you will have what we call an open dot. So I'm going to draw an open dot underneath it. So because if a symbol in an inequality is less than or greater than, your dot will look like this down here on this second example. That second example, notice it's just open. And that means that the line comes really close to that value. For instance, this line comes really close to 1, but it never actually touches. And in some instances, we have a closed dot, like you can see on this first example. Now that one, I'm going to draw another set of these real quick. Let's say we had greater than or equal to, or less than or equal to, right? Less than or equal to, or greater than or equal to. In this case, we're going to have a closed dot. And that's because it actually touches that value. It makes contact with it. For instance, if we go look at this first one, that's telling me that this particular line that we have right here, it actually touches -2 on the number line. So just keep in mind, we know which inequality symbol to use based on if we have an open dot or we have a closed dot. Now, the first notation that I'm going to write is what I think is the most simplest notation, and we call it interval notation. So when it comes to interval notation, the way that it should look is we want to find our least value, in other words, the furthest it goes to the left, and then our highest value, the furthest it goes to the right. And we're just going to put it in either parentheses or a bracket. Now when I say a parentheses or bracket, to go ahead and add some more imagery up here, we are going to use a parenthesis if we have an open dot. We're going to use a bracket, when I say a bracket, it looks like this, if we have a closed dot. So just keep in mind that those kind of go together and these go together. So on this interval notation, I want you to notice that I have a closed dot that contacts the point at -2. So what I'm going to do is I'm going to go ahead and I'm going to draw my closed bracket, and I'm going to write the number in there, -2, and then I'm going to put a comma. Now that's the furthest my graph goes to the left. Next, I need to document on the right hand side my greatest value, or the furthest it goes to the right. Now in this case, we don't have a greatest value to put in this right side because it doesn't stop at one of these points. It just continues on infinitely. And in Algebra 2, we actually have a symbol for infinite, which means that it goes on forever. And the way that symbol looks is like a sideways 8. So I don't know if you've ever seen one of those symbols before, but this is an infinite symbol. Now, it is an infinite symbol, but because it doesn't stop on a particular number, it's not finite, we are going to go ahead and put a parenthesis on it. Right? Because notice there's no dot over here. So when we don't have a dot, there's not a place where it stops that's a solid dot. We are going to go ahead and use that parenthesis, showing that it's infinitely moving to the right, never ending. It never terminates. Now that's interval notation. So let me show you how that would look if we wrote that as what we call set notation. So set notation is going to use this ideal that you see right up here. This is set notation. And one of the things is this x, this first x that you see right here, it just stands for all real numbers of x. And this line that you see that's kind of breaking it in half, that almost looks like an absolute value line, or at least that's what it reminds me of. When we see that line just means that such that. And then this right here is going to be an explanation. In this case, this said x is less than a. Well, we're going to write it similar to this, right? But it's going to be based on this situation down here. So I'm going to start off always the same way. I'm going to go ahead and draw my bracket. So I'm going to come over here and draw this kind of odd looking bracket here. And then I'm going to go ahead and put my x. I'm going to put my line. And then I'm going to put an x again. Now this is where things can change. In this particular situation, what we notice that we have is that I have a solid dot, right, at 2, negative 2, which means x can be equal to negative 2. And then it moves to the right infinitely. So not only can it be negative 2, but it can be any number that's greater than negative 2. And so if I want to say any number that's greater than negative 2, and I want to say they can also be negative 2 as well, the best symbol to use is going to be greater than or equal to. So at all times, x can either be equal to negative 2 or greater than negative 2. All right, so we have x is greater than or equal to negative 2. And so right here, I'm just going to put negative 2. Now I'm going to go ahead and close my bracket. And basically what we're saying here, if you wanted to read this, is we're saying that all real numbers of x such that x is going to be greater than or equal to the value of negative 2. And that's because x can be negative 2 or any number greater. So that's the second way. That's set notation. Now, if we just wanted to write an inequality representing this particular situation, let's say this was representing domain, right? How far we move left or right, which is what it is. Then we could just simply write the inequality. We could write this as, if we write domain, and that was an x-axis, we would just say x is greater than or equal to negative 2. And that's what you would have done in Algebra 1 if this was an x-axis and somebody asked you for the domain. But now we're also going to be using set notation and interval notation. So let's take a look at another example that's very similar. So I'm going to move this down just a little bit. So first I'm going to start off, I'm going to write the interval notation on the right and set notation and the inequality on the left. So if I want to go ahead and start out, I notice that I have an open dot. And remember what we said earlier was open dots means that you're going to go ahead and use a parenthesis. So for the interval notation, I will simply draw a parenthesis. My value that's furthest to the left is positive 1, so I'm going to write a 1 in there. And then I'm going to put a comma. And the greatest value to the right, it goes on forever, so it's going to be infinite. So I'm going to go ahead and draw my infinite symbol. And then I'm going to close parenthesis on it. And that's my interval notation. Now, if I want to go ahead and use my set notation again, I'm going to leave a little space right here. So for set notation, we're going to draw our bracket, our x, the line, and then I'm going to go ahead and draw x again. And now what I want to do is I want to consider, is it going to be greater or less than this value of 1? And in this case, right, it's going to be greater because it moves to the right. So I'm going to simply put a greater symbol. Notice I did not put the little line underneath like I did on the one above. And you know what, I should draw a line to separate this so it doesn't look like it's the same problem. The reason we didn't draw that little line on our bottom is because this one's an open dot instead of the first one that was a closed dot. Since we have an open dot here, it can never be 1. But it could be any number above 1. It could be 1.1, 1.2, and so on. It'll never be 1. It can't touch it. You can just get really close. So I'm going to put x is greater than 1. And then I'll go ahead and I'll close the bracket. If I was asked to write an inequality for this situation, I would just simply write this as x is greater than 1. So there's 2 examples. So I'm going to show you just a few more. Let's go ahead and take another one. Let's move down. I'm going to go ahead and draw a line across here so we don't kind of confuse it with the previous problem. Just another example for you. So let's say we have one here. Notice this one's different than the previous because this one has 2 points, right? So it terminates. It doesn't continue to go on infinitely. So we're not going to be using that infinite symbol. And I think these are even easier, at least in my mind. So when I see one like this and I say, okay, my lowest value is negative 4. My highest value that it goes to is positive 1. And they are closed dots. It has 2 closed dots. So what I'm going to do is for my interval notation, I'm going to draw a bracket. And my lowest value is negative 4, so it goes on the left. Put a comma. My highest value is positive 1, so I'm going to put it on the right. And notice that is a closed dot, so I'm going to put a regular closed bracket on there. So that's my interval notation. It goes from negative 4 to positive 1. Now let's go ahead and let's do the set notation. Now if I'm doing set notation, I'm going to go ahead and I'm going to draw my bracket. I'm going to write my x, and then, now this one's going to be a little bit different because after this, notice, right, we just didn't have 1 point and then going off and infinitely, right? In other words, it didn't look like a ray if you're taking geometry. We have actually 2 points. So I'm going to find my lowest value, and in this case, my lowest value is -4. So I'm actually going to write right here, -4. So my lowest value went on the left, and then I'm going to go ahead and say that that is going to be less than or equal to, and I'm using less than or equal to because it's a closed dot, it's filled in, it's not hollow. I'm going to say x, which is then less than or equal to this +1. And then I'll go ahead and close bracket on it. And that's my answer. Now, if I was just wanting to write the inequality for this, I could simply write this. If we were back, if this was an x-axis and I told you to find domain for algebra 1, we would simply write it as -4 is less than or equal to x, which is less than or equal to 1. So this is written as an inequality. This over here is written as what we call set notation. And this is written as what we call interval notation. So let's do another one. Let's try another one. So notice this one has an open dot and it has a closed dot. So it's going to look a little bit different than this one that we have here. So I'm going to draw a line, just separating it. Now first, I'm going to go ahead and start with my lower value. It's -5. So I know that I'm going to have a -5 on the left, comma, and my greatest value is +3. Now I know that my -5, my lowest value, it has an open dot. It's not filled in, so I'm going to use a parenthesis. And I know that the 3 has a filled in dot. It's closed, so I'm going to use a bracket. So in this case, right, since we had 2 different situations, it can't touch -3, but it can get really close. I'm sorry, -5, but it can get really close to it, and it can actually touch +3 and be anywhere below it. So that's my interval notation. If I do set notation, I'm going to go ahead and set up my bracket. And I'm going to put x, and in this case, we're going to start off the same way. I'm going to find my lowest value, which happens to be -5. So -5. Now, instead of using the less than or equal to like we did up here, because it's an open dot, I'm just going to use the less than symbol. I'm not going to put a line underneath it because it can't actually touch -5, but it can get really close. I'm then going to put x, and then I'm going to say that this is going to be less than or equal to +3. Now, I am done. I'm going to go ahead and write my bracket at the end. It has a little point on the end of it, right, which represents that this is a set. I call that a bracket, but it basically just means that this is a set. So I've written it in set notation, I've written it in interval notation, and if somebody asked me to just write the inequality, I would have just written as -5 is less than x, which is less than or equal to 3. All right. So we have our final way of writing it. We have one more example to do, and then I think you'll be ready to tackle all the work you have. Let's take a look at this one. We're going to start out by writing it in interval notation. Notice it looks a little bit different. We actually have 2 rays that are pointing out to the right. In other words, you have, all right, a starting point here, and your line goes out to the left. We have a starting point here, and your line goes out to the right. So in this one, we're going to use something called a union to show both situations. Now, when we write it in what we call interval notation, I'm actually going to start with this one on the left, and I notice that it goes negative infinitely. So if I wanted to write that, I would just say, okay, it's going to go negative. Let me draw it right here, negative infinitely. That's what that symbol means. Go ahead and separate this. And then after that, I know that it can go as far right on this first one as -2. So I'm going to put comma, and then I have -2. I am going to use my parenthesis instead of the bracket, right, because it goes on forever. And on the right, it's an open dot, so I'm going to use parenthesis again. And then I'm going to put a U for union. Now, when I do the next one, this one on the right, I want you to notice it has a closed dot at 4. So for that one, we're actually going to use a bracket, and then I'm going to put 4, and then it moves infinitely to the right. So I'll put comma, and I'll put my infinite symbol, and then I'm going to close it with a parenthesis because it goes forever to the right. It doesn't stop at a certain point. It just continues to go. So this is my interval notation for something that has 2 different lines graphed on it. And now we're going to go ahead and go to our next one. So we're going to do our set notation to see, so you can see what that looks like. So I'm going to draw my little set bracket. I'm going to put X, draw my line. And now that I've done that, I'm going to start with this first one. So on this first one, the situation is X is going to be less than -2. And I say less than, notice I didn't put the less than or equal to because it has an open dot. So it's less than -2. So it could be really close to -2 and anything that's below. Then I'm going to put the word or, right? Instead of putting this U symbol, we're just going to put the word or. And then I'm going to say X can be greater than or equal to. And I said greater than or equal to because we have a closed dot that's filled in, and it's going to be +4 because it can be 4 or any number that's greater than that. I'm going to go ahead and now write my bracket to close it, and we now have our answer for set notation. Now the last thing, if somebody said, oh, can you go ahead and just write the inequalities? If you wanted to, you could simply write it as X is less than -2 or X is greater than 4. So hopefully this clears up some misunderstandings, and you can continue to be successful in this particular topic.